Today we're going to be talking about how to leverage large language models inside of BigQuery to activate your data. I have a few of the colleagues here, but myself, I'm Michael Kilberry. I run product for AI ML across data analytics here at Google. So you might have heard BigQuery, Looker, BigQuery ML. These are all products that I work on. And I'm really excited to show you about the latest innovations we've been doing in this space. But also I have Dr. Michael Chin from Unilever here to showcase some of their journey at Unilever building Gen AI applications on top of BigQuery, along with my colleague, AI specialist, Deborah Lee. Looking at the agenda here, I'm going to talk your off for a little bit because we have a lot of things to cover. We've been working on a lot of awesome capabilities for Gemini in BigQuery, using different LLMs and different techniques in BigQuery, but also going to be showing some demos. So I'll be showing a really cool Gemini Pro Vision demo, and then Unilever is going to walk through one of their own demos around geospatial and Gen AI. But getting right into it. So a lot of customers right now are seeing what LLMs can do for their business. They're seeing how they can enrich data, how they can extract insights out of traditionally free text or data that would be very cumbersome for a human to analyze. But now LLMs are having a new frontier to analyze this data. And we're seeing also, too, not just LLMs being able to analyze this data, but many customers have a large corpus of data, unstructured data, semi-structured, and structured. And right now, there's a lot of limited techniques to be able to ascertain insights from this entire data corpus, namely unstructured data. And I'll be covering a lot of techniques today around what we're doing within Gemini for BigQuery and Gemini in BigQuery, which I'll show some distinctions there later, around what we're doing to help you be able to analyze unstructured data in this space. But also, too, we understand that AI is not very easy for people to use. There's been a lot of machine learning techniques that have been on the market for quite some time. And many of us are probably SQL professionals, some Python professionals, but maybe not many of us are actually true data scientists. And one area that we're really focusing really keenly within data analytics here at Google is being able to lower the bar of entry to be able to do machine learning and advanced AI workloads using things just as simple SQL. And I'll show that today later as well. And finally, we're seeing a lot of companies needing to be able to build AI-driven data experiences, whether it's being able to enrich your current data pipelines with LLMs directly in the mix to be able to enrich data, improve it. But also, we're seeing the advent of agents, customer conversations being driven by LLMs. And fundamentally, all of these agents are really based upon your enterprise data. So if you don't have good enterprise data and you don't have a good means of data to build these foundations upon, you're not going to have a really great AI experience. So really, we're really focusing on building our data analytics platform and being a really true data to AI unified experience. And just a quick overview about some of the customers we already have leveraging LLMs inside of their data analytic pipelines and in their AI workloads. For example, Priceline currently connecting millions of customer data points together regarding hotel information, marketing information, other types of social demographic information, and unifying that with their own business data in order to ground their agents in reality, business facts, so that for when they're working with their customers to plan a new trip, they're not going to be hallucinating hotels that don't exist. They're going to speak confidently on what actually is there. Furthermore, we also have a company as cutting edge as Faraday, who's actually a co-speaker at one of our other sessions on this topic, where they're using LLMs directly in a pipe to enrich customer profile information, customer review information in order to help retailers and product manufacturers get the best understanding of how customers are using their products and using LLMs to extract those insights very easily. And you look at our entire portfolio across the gamut of Google, we're really focusing on many different areas that really meet our customers with our efforts, using operational stores with AlloyDB or Spanner, or using our blob storage service with GCS, or using BigQuery to analyze all that data, not just from these other properties, but in the combination thereof. And also, of course, our partnership with Vertex AI, where we built the industry-leading capabilities with Gemini and infrastructure to be able to run inference at scale. And also Looker, too, being able to bring a lot of these higher-level data insights directly to business users who don't need to speak SQL, but want to speak conversationally to this data. We're really thinking about how we can bring all of the best of AI capabilities across this entire data stack. So looking right into it and jumping into it, you probably have seen during the keynote our focus on a new service that we released called Gemini in BigQuery. And you've heard the term Gemini many times, and I want to create clear distinction about what Gemini in BigQuery is. Gemini in BigQuery is our assistant platform and allows us to offer up many different services, whether it's to generate SQL code for you, to be able to proactively analyze your data and make recommendations, whether it's materialized views or clustering, or also automate other operations that typically a human in a loop would have to perform. But Gemini and BigQuery is really offering this platform of AI-driven assistance across the entire data analytics stack. And diving a little bit further into another key feature of that is, like I mentioned, is Code Assist. So many of my customers have been asking lately around how they can use NL to SQL or natural language to SQL in order to have this basic conversation expose data inside of BigQuery. Well, we heard this loud and clear, and we started to build a first-class service in Gemini and BigQuery to offer that up. We have this capability not just within BigQuery Studio and inside of SQL Worksheets, but we also have this capability showcasing in other areas within Google, which I'll cover here in a minute. But I want to really cover right now is many of our organizations currently have a bottleneck with their data teams. There's a lot of interest in being able to leverage enterprise data across their organization, and oftentimes business needs responds very quickly to creating new data products, and maybe the data team is backed up. But being able to bring more of these capabilities to business users, you're enabling a larger group of your population in your organization to be able to act upon insights at a much faster rate. And even when we consider about NL to SQL, there's a lot of other ways that we want to see that work for even business users. So one other interesting way we've looked at this is to create something called BigQuery Data Canvas, which takes Gemini in BigQuery and embeds it directly into a new visual-driven notebook-like experience for you to do analytics at scale using LLMs directly baked into the service. So whether that's simply asking for, tell me the top 5 products that have been sold across North America and rank them by state, and then it provides that table for you. But then if you want to quickly visualize that table, you can also use natural language in order to generate charts as well and link these two together. And you can see the chain of thought as well as you're creating these notebook-like experiences, what we call canvases, inside of BigQuery, so you can see the full fidelity of workflow that was used in this process. But like I mentioned, LLMs are baked into every single aspect of this service. Also, too, you can share this service. So as you construct your canvas, you're able to share that across the organization, much like how you would use a Python notebook, a Jupyter notebook. But this is really built around the SQL experience with LLMs built directly in it. Now looking at another area that we've done significant amount of investment in is something called BigQuery ML. So you already know about BigQuery, our large-scale data analytics platform, and along with Vertex AI, our AI platform. But like I mentioned earlier, there's a large gap right now in the industry with people having true ML engineer experience and capabilities to act upon that, and then a large population of people that still know SQL. And so we're really looking to how do we solve this problem to bring more AI capabilities to people who know SQL. So with the advent of BigQuery ML, we really have built a single-class user interface using SQL to interact with Vertex AI directly inside the context of BigQuery. So you can train models, run inference, do fine-tuning, generate vector embeddings, use LLMs directly in the pipe. And this is all back-ended from Vertex AI. So we have a really deep partnership and integration across both of our platforms. And looking a little bit deeper into the capabilities of BigQuery ML, like I mentioned, we do training and fine-tuning, which is typically an action would be a lot of lines of code in a Python notebook, but now we give you a handful of lines of code in SQL to perform those same types of actions. It's often built to be very simple to use. Like I mentioned, really focused on the data professional persona, people who know SQL, who do not know traditional ML techniques. But we provide that all inside the BigQ experience for you to be able to work directly with your data with AI in place. So you don't have to worry about moving data to yet another silo to do AI operations. You can do that directly in place all inside of BigQuery, and also leveraging all of what BigQuery has to offer with our unified governance, security, logging, metadata store. All of that still comes to bear as you use machine learning techniques on top of that with BigQuery ML. But also we have traditional ML too. So we aren't just all generative AI, we also have predictive ML. So think about forecasting or anomaly detection, things of this capability. We also have that inference as well built into the service. And it's taking another look at other things we've launched within this space too. We recently have GA'd model training via SQL integrations, like I mentioned with Vertex. We also have recently released some areas within predictive ML around multivariate time series forecasting and explainable AI. We also have integrations too with Vertex Feature Store, so you could do feature engineering directly in BigQuery and have a managed sync of those features for online serving with Vertex Feature Store. But some other areas that we've recently expanded into is remote inference using any model within Vertex AI, where you can choose a model targeted within Model Garden and leverage that for either generating embeddings, generating text, summarization, transcription, and I'll show a little bit of examples of that later. But other couple of things I want to call out here too is really our investments in multi-modal support. So as you saw with our keynote with Gemini 1.5 and all the capabilities it has to be able to do analysis across text, video, audio, we're bringing that same the same model to bear within BigQuery as well. So as you store multimodal data, such as PDFs with images, audio files, video files, et cetera, you'll be able to use these same multimodal techniques against all of your data in place. So looking at a quick high level of all the different capabilities you can use BigQuery ML for, there's several different functions here that you'll see that cover the whole gamut of LLM types of function calls. So starting on the upper left there, you'll see we have a handful of now vision-supported techniques, whether it's annotating an image or generating text to explain what's inside of the image, which actually we'll demonstrate a little bit later. And we're not starting just with images, too. Very soon on the horizon, we're going to be rolling out video support. So you'll be able to analyze video segments as well to be able to do summarization and pull out what's in there. But not just on the video side, we're also supporting things like with speech to text. So we have a capability with ML Transcribe, working with our API for Transcribe inside of Cloud AI, to be able to feed in audio files and pull out text for analysis. For one example, we have a large financial services company that uses audio files of their traders and then extracts entities out of there, whether it's stock prices, purchase decisions, out of those calls and use that for auditing purposes. So again, allows you to break out information from unstructured data and then put it into a structured format for downstream analysis. Moving into more of the traditional stack around text, you can see we have a bevy of different functions that cover both data enhancement, entity extraction, but also generate embeddings, which is really an emerging capability for us. If you've seen anything around RAG or retrieval augmented generation, one key piece about grounding LLMs in enterprise data is being able to use a RAG approach where you would generate an embedding of the prompt, and you compare that embedding to data you already have stored inside of BigQuery to see what that prompt is similar to, and then you return back results that are most germane to that example. And so this allows you to ground LLMs reasoning inside of enterprise data. And this is a very large focus for us at BigQuery because many of our customers are aggregating all their data in BigQuery and looking to generate embeddings in place upon that data, and then being able to serve from that from a single spot rather than having many different data silos being built. Also, too, not just with generate text and embeddings, but we also have things like translate. As you probably saw with Gemini 1.5, removing an ability to be able to cover even more languages in the world. And this is a common thing for many of our multinational customers who are looking to do very simple translation in data that they already have in place. And also, as I mentioned too at the bottom there, we also have BQML-specific models built around traditional predictive ML. And I also don't want to shortcut that. As much as we love generative AI, and everyone loves talking about it now, there is still a really good case for forecasting and anomaly detection using predictive ML. And I also would make sure that folks still don't forget about predictive ML, as it's really gotten us pretty far to date. But looking a little bit deeper into some of these other areas of integrations and double-clicking into some of those functions. So I mentioned there we had speech to text as well as a document processor called Doc AI, which allows us to use OCR techniques to extract information out of PDFs, leveraging, again, APIs that we have in Vertex. But leveraging all of that through BQML, you don't have to worry about setting up additional permissions or cruft or infrastructure. You're just able to use that as a simple function call. And using that inside of BigQuery, you're able to use the serverless capabilities of BigQuery to run and scale these operations. Also, too, as I mentioned with Gemini 1.0 in BigQuery, we just launched Gemini 1.5 public preview here. We'll also be bringing Gemini 1.5 to BigQuery here very shortly. But with Gemini 1.0 Pro model, that's still a very state-of-the-art model that many of our customers are already leveraging in production in BigQuery. And I already mentioned Faraday earlier, but they're really doing a fantastic job. I'd also recommend taking a look at the Faraday session if you can go back and see the on-demand sessions where they walk through how they've actually built their platform upon harvesting customer data, product information, and using LLMs to enrich that for retailers across the world. But I want to dive a little bit further into some of the use cases that we're seeing most commonly used within LLM and data AI pipelines inside of BigQuery. One big one is sentiment analysis. So think about free text that you might have in different scenarios. Often, this is very common for retailers, where they maybe have free text in of a product review, customer review, and they want to extract themes or they want to measure sentiment of that. Typically, it comes in free form, but when you pass it to an LLM, you can provide it the prompt around giving it a scale and giving it a sentiment of what you're looking for to grade, for example, a review on whether it's highly likely they like it, neutral, or they're detrimental to the brand. And it also even pull out sentiments too, like, or rather entities around, are they referring to the order of the product or the difficulty it is to construct it? LLMs are able to reason over free text and pull out these themes. And many of our customers are using that in their data pipelines in order to enrich these free text pieces of data they have and to make it more actionable for their business. Kind of refers to similarly with the data enrichment, but again, with entity extraction very commonly too. When you have free text, you may be very common in the healthcare scenario, they might have doctor's notes or other kind of free text that they have from patient information where they want to extract out medicine prescribed or different prognoses that are made. And typically these are either handwritten files or free text that a human in the loop would need to be very aware of the given domain that they're trying to extract entities from. But with Gemini, not only will it have very large inherent understanding as it's a large foundational model, but also you can fine-tune it on your specific domain as well. So if you're fine-tuning for entity extraction on, let's say, pharmaceutical prescriptions, or you're fine-tuning it upon your specific product, you can offer up eval data and use supervised fine-tuning within BigQuery in order to make sure that it's really focusing and extracting the correct entities out of that content. Of course, there's also traditional content generation. You can have Gemini, as you probably have seen in the more commercial standpoint, generate free text, if you will, on your own, where you can have it potentially add summaries or do example cases of writing that you would grade upon. So many our marketing customers are using this kind of capability to generate A/B testing around campaign language that they want to use in advertising. Also looking to beyond just traditional text, but also some of the new capabilities now that we have with Gemini Pro Vision, we can also do things like image analysis and entity extraction from images, which I'll actually show in my demo. But think about if you're presented a picture and you want to ascertain what's actually inside of the picture, you can actually just prompt Gemini to pull out those objects and then store that in a JSON. Or you can ask it to do a count, or you can ask it to look for potentially nefarious things. Some of our customers are using it for safety purposes, for content screening to make sure that there's themes or things of that are not being uploaded. But also, many of our customers in the retail space are also using this to analyze, think for example, like a marketplace akin to an eBay or a similar type of construct, where customers would upload pictures of their products, and you want to make sure that the description of the product they are saying actually matches the image that they're putting up for that profile, that product. But also entity extraction too. Similarly, if you have a file, or excuse me, you have an image and you're looking to pull out, oh, what kind of car is that? Or what kind of product is that? You can ask these types of questions and again, similarly format it into a structured piece of data that you could do downstream analysis with. So I want to talk a little bit more about support for Pro Vision inside of BigQuery, because as I mentioned, we're investing heavily in multimodal space, and really vision is a key part of that. But like I mentioned earlier about using just a handful of lines of SQL code in order to get started with this, and you can see here in this example where we create a model with 3 lines of SQL code in order to start that model and create that within Vertex AI. And then from there, we then select a generate text function where you can see here where we pass an object table, which is a primitive, which allows us to organize and manage unstructured data from GCS inside of BigQuery. But you can also see where we interject a prompt. And I'll actually show a little bit deeper example than this slide here in a minute. But just again, looking at the entire gamut here and seeing where we are fitting in with vision here in the upper left-hand corner is really currently around that generate text. So although generate text might seem a little broad, but you'll see here in the demo about when we say generate text, you're generating text about the image. So in your prompt, you'll ask maybe like, please describe what's inside this image, or please analyze some aspect of this image, and it'll generate the response, and so we call that generating text. So I know it's a little bit of a newer language to learn regarding generate text versus the other generate text you see on the other side, which is, of course, generating text for text. This is generating text in the context of vision. But now I'd like to move on to a demo where I'm going to show off some of the capabilities here inside of BigQuery. So here right now, I'm inside of BigQuery Studio, and I'm currently operating inside of a notebook. And so here, I'm just doing some basic preparation for this example where I'm loading in some Python libraries in order to be able to demonstrate showcasing images and interacting with Gemini Pro model. So here, I'm showcasing how I'm building this inside of Python, but of course, I'll also showcase how I'll do this inside of SQL as well. So right here in this cell, I'm going to go ahead and create that Provision remote model, and you can see it created very quickly. And all it's simply doing is targeting the Pro model already inside of Vertex Model Garden and creating an instance for me. And then from here, I'm going to go ahead and load images from Google Cloud Services, Google Cloud Storage, into a bucket, and then create an object table over that for management inside of BigQuery. So here I've now loaded in images, which in this case is a handful of cars. So let's assume I am a car reseller, and I'm looking at allowing customers to be able to put up their cars for purchase, put an image, and then compare that image to the car that they say that they're selling. So for this example, I've uploaded images of a handful of cars to this given object table. And so we can see here that we validated it. Now, from this case here, just kind of walking through earlier, in this prompt here, I'm asking, what is the brand, model, year of this car? And so you can see all I'm doing is one line of SQL inside of this select statement, and this select statement is over that object table. So I'm simply saying, from this object table's images, I'd like for you to generate text that describes what is the brand, model, and year of these cars. So running this, given inference is rather, runs rather quick, and again, we orchestrate all of the infrastructure behind the scenes for you. And so in this scenario here, we now have Gemini's thoughts on what these cars are. And you can see that it's a little bit of liberty in how they decide to answer it regarding, you can see the first one here is referring to, oh, this car is a 2013 Nissan Versa, and this other one is very much more verbose. I think it's a BMW. So you can see it's a little bit free text itself. But from here, I like to make it much more focused around formatting that data. So rather than having free form, I want to make sure I can flatten into a JSON and actually use that for additional downstream analysis. So in this scenario here, in this cell, and you can see now we're actually using SQL because I've actually done BigQuery here and turned this into a SQL cell. So again, similarly, just a handful of lines of SQL, passing that object table in, then asking that same question, but making sure I flatten it into a JSON output. And then here I'll ask about that same thing. And here we go, I'll run it real time. So now we complete it here. You can see that we have now a formatted version of that text against those images. So again, you can now take those images and then use this JSON and do additional downstream analysis if you wish, whether you're joining it or using it for semantic search. A lot of other capabilities you can have now with that used. Furthermore, too, we can also add this to a table with additional metadata to now construct regarding our inventory. So now we know we have an inventory of an Audi S4 of 2009, and so on and so forth. But again, this allows us to simply extract out inventory information and other metadata where all we had was just simply the image prior. One thing I wanted to note, too, is that you can also use Gemini and BigQuery ML to fine-tune these examples. So while I just use this as Gemini out of the box, you can also have eval data to train and fine-tune Gemini to make sure it's even more certain upon what it's analyzing from these images. So again, if you're doing it for a specific domain, potentially your own product catalog, if you're a retailer, or a set known of cars, if you're a car reseller in this particular scenario, you can, of course, fine-tune that for those purposes. Now, going back to the slides, I want to show another capability that we also have building on top of.
By now, you've probably had.
There we go. So I wanted to show more around BigQuery vector search. So I mentioned one of the techniques that we have inside of BigQuery ML is the ability to generate embeddings. So vector embeddings are mathematical representations of a piece of data in a contextual space relative to other pieces of data. And as you generate embeddings, it's put into a 3D space. So imagine, if you will, a case where a dot is pointed and for a particular piece of data. And as you create new data, generate embeddings are then placed in that same 3D measure. We measure that 3D space to determine what things are near each other, and from that we can determine similarity from that. It's an interesting mathematical approach. I'd highly recommend watching a cool YouTube video on breaking it down. But for those who do know, we offer that capability native now with inside of BigQuery, where you can generate embeddings directly in place. But also you have the ability to now use vector search indexes directly in place with BigQuery as well. So after you generate those embeddings, you can then use BigQuery vector search to do that similarity searching I was mentioning earlier. But one of the key pieces here too is not just similarity searching, but also semantic searching. So if you want to get true semantic understanding of what you're looking for, not just keyword detection, but true contextual understanding using language, this is where semantic search comes into play and is capable of then using with vector search from BigQuery. Also should be noted too within BigQuery for vector search, we also have support for LangChain and vertex extensions as well. So you can orchestrate this and use this with your models and with your own AI workflows that you already orchestrated with LangChain. But a few other mentions here and other use cases, mentioned similarity search, semantic search, but the really big one here is around retrieval augmented generation. So similarly, if you're getting a prompt to an LLM and you want to compare that to results you already have known, as I mentioned, you would generate that embedding for that prompt, which is similarly creates that vector with dimensionality, and you then compare that to other answers you already have inside of your vector database so you can quickly find what this prompt is most reasonably matched to from an answer point of view. But I also want to showcase too about what we've done with our integration with Vertex AI. Because BigQuery is built as a large-scale analytics platform, really building for large-scale processing, but we are admittedly not built for online real-time serving. This is where our capability and integrations with Vertex come into play. So we have managed sync between us and Vertex feature store, and as well as other properties we're currently working on across Google. So we're also working on the same capability for Vertex vector search along with AlloyDB and Spanner. But the idea is many of our customers already have a lot of this data in place inside of BigQuery, and so organizing that, being able to test and prove out that the vector search is high quality at a very good price point. So if you have analytical needs, you can serve directly from BigQuery, but if you have, let's say, high QPS, low latency needs to serve real time, potentially for an external website or chat agent, that's where you could take that data inside of BigQuery and then sync that with Vertex for online serving. So now I'd like to pass it off to my colleagues, Deb Lee and Dr. Michael Chin from Unilever to discuss about the Unilever story in Gen AI.
Hi. Thank you everyone for joining today. I'm Michael, and I just want to give a brief overview of sort of Unilever's journey onto BigQuery and how we started. Super simple, and we're really just starting to get to the point to start taking advantage of the really cool features that are coming out that Michael talked about briefly before. Before I start getting into that journey, let me give you a brief overview of who we are within Unilever, within procurement. Our team sits within strategy and insights. We're running a small analytics engineering team within strategy and insights of procurement. And strategy and insights itself is almost run as a kind of advisory board to procurement, where we sit between leadership and the buyers to help drive larger strategic innovations. And so as a part of that, you can imagine data is a pretty large aspect of what we do. Traditionally, up until now, what we've typically have done is work closely with our central IT and DNA teams to take a lot of the data that's sitting in our internal data lakes and a lot of the data sets that they help manage to drive further downstream analytics. We manage a lot of the data sets and some of the dashboards, and we present that to our team of analysts and our buyers. And so that's sort of where we are right now. To give a really brief recap, our team is a smallish team of analytics engineers. Our primary tech stack is probably working in PySpark, Databricks, but really serving up dashboards in Power BI and helping and supporting our analytics downstream data analysts. But for what I wanted to talk about today is like, how did we start getting into BigQuery? How did we really start using that just as a basic analytics tool? And during that journey, we started seeing more and more opportunities to integrate more data into the data sets that we were exposing onto BigQuery, and to start really leveraging some of the more advanced tools that were available to us, and how having that all in the same ecosystem really inspired our teams to continue pushing those boundaries and furthering the analytics within that space. So where we really got started with BigQuery is sort of along our journey of looking into graph databases. We were starting to develop graph databases as a means of doing analytics across what would be a really complicated network in our supply chain. On the outset, what we really wanted to do was find a better way to run analysis across that supply chain, going from our supplier, through invoices, through our bill of materials, down to our finished goods, and really be able to attribute all that spend going from suppliers down to our business groups, down to our finished goods. And one of those tools that we wanted to start relying on was graph databases. Now, graph databases were really great for setting up that complicated schema and that querying across that complicated schema. But where we started finding bottlenecks along the way was that at some point we still needed to expose that data to data analysts and buyers who did understand the business. And that was causing problems with us because GSQL is a fairly niche querying language, and we weren't yet set up to scale the implementation of that database. So we decided, let's offload that onto BigQuery. And that would probably help us expose a lot more of that data set that is coming off of that graph database. And once we started doing that, we really started seeing a much higher turnover of our iterations. What we really wanted to do was expose the output. It's like, do these numbers look right? If not, then let's go back to the schema, to the GSQL, and continue to iterate until those numbers are lining up to what are the expected numbers from the buyers. And so really that's kind of our first step into BigQuery, just really basic applications of using it to query tabular data. But once we had landed that data there and we felt pretty confident of that data set there that was taking us from that journey from supplier all the way to our business groups and being able to help us finally allocate our spend across these different divisions, we start realizing this is a pretty convenient launching point or place for us to add other pieces of data onto there too. Pieces of data that haven't typically been attributed down to those business group levels. One such example of this data set is the really good work that our sustainable sourcing team has worked on, especially in analyzing carbon generation for palm plantations and attributing that down to our palm suppliers. And as a fairly straightforward exercise of combining the two, we're able to now leverage that information and now understand how does that relate to specific business groups and brands. And then from there, we started asking ourselves, well, what else can we do with what is in our ecosystem? And again, with our sustainable sourcing team, they've leveraged quite a bit of Google Earth Engine to derive a lot of that carbon data. And we took the next step and said, well, we do have a lot of invoice and pricing data and a lot of market intelligence data. Let's start combining these two to start building out explainable pricing and forecasting models for buyers to help them understand a little bit of what are the forces that could be driving their prices going on into the near future. And so we started adding a little bit more and started exploring a little bit more into that space. And with working with Google, of course, and understanding that Gemini large language models are a huge unlock for us, especially in the realm of unlocking the explainability of our data. That's one thing that we started exploring. At first, it was fairly simple use cases of understanding, can we just spin up a fairly basic question to SQL translation and allow users to be able to sort of talk to their data a little bit more naturally. During that exercise, we did come to understand a lot about implementing large language models across our data, for example, prompt generation and the importance of a RAG on top of that querying. And now that we started dipping our toes into some of Gen AI and our data, and being able to expose that to our buyers and the rest of the procurement community, really had an explosion of sort of inspiration of what else we could be doing, and that's really leading us to where we are right now. One of those efforts that Deb will be talking about is a really cool implementation of asking, using LLM as sort of a reasoning engine of, let's say that we wanted to ship components from the supplier to a plant that normally hasn't been shipped to, where we haven't really established the cost models of that shipping. Can a Gen AI propose port combinations that make the most sense in the given context of what we're looking for? Other examples that we're expanding out onto are parsing out contract intelligence, where we're partnering with GoReply to help us pull that information out of our contracts so we can do further analysis. And I think I briefly talked about the use of traditional ML and forecasting techniques to help bring that sort of explainability to the buyers, but being able to do that in a self-contained system that is all within BigQuery. So that's a quick rundown of our sort of journey, like starting super basic and really just starting to get to the point where we're exploring the full richness of what's available on BigQuery. But let me hand it off to Deb, who will go through that port mapping exercise that we talked about.
Good job. Great. If you could just switch over to the other screen. So I'm going to actually sort of jump back and forth between an interface that we've had users from Unilever experimenting with, iterations, giving us feedback, and then kind of pull the curtain back to show you how some of the RAG functionality, embeddings models, and tight integration with Vertex AI is powering applications like this. And just to give you a sense, like this is something that the team has been able to spin up, start prototyping, experimenting with in the matter of like days or weeks. So we're no longer talking about a 4 to 5 month sort of project just to see if some of the initial results are good. The integrations from a Gen AI perspective in BigQuery are giving us sort of massive speed and efficiency gains here once the data is already in BigQuery to start playing with, enriching. So from a logistics standpoint, we can see here the sort of complication in terms of the fact that Unilever has 55,000 plus suppliers. They have a lot of different manufacturing plants. Shipping lanes sort of can be changing. So maybe historically, just because something was shipped this way from origin to destination doesn't necessarily mean it would be the same way again. So we both want to sort of capture sort of our best guesses in terms of what might be the best route, but also sort of capture user feedback, because a lot of this sort of domain knowledge is still sitting like largely within the logistics sort of analytics teams. Like, so they just sort of know, oh, well, it's obviously going to be this shipping port, or it's probably going to be this way just because of X, Y, and Z reason. So what I've just done here is sort of selected one of the Unilever manufacturing plant sites here. We have in Durban, South Africa. So when we do sort of the return the closest ports to plant, behind the scene, this is actually sort of taking the initial query, which is that plant, it's turning it into a vector embedding, and then performing the similarity search against all of the different locations from a ports perspective behind the scenes. So our red dot here is where our plant is, and then we can start to see now, all right, these are where, from an embedding sort of similarity perspective, like in our embedding space, this hasn't even been fine-tuned either, where these might be most similar to each other. And you can kind of see these dots are overlapping, right? But oftentimes there isn't a super close dot necessarily to the next one. And there are always considerations for where is that shipment actually incoming from. So is it coming from, is it coming from Asia? Is it coming from North America? Is it coming from LATAM? So sort of the directionality comes in there. What this is actually doing behind the scenes is we have sort of the BigQuery vector search. I'm going to zoom in because there's a small capability sort of being run behind the scenes in this application, so at the time. However, what the team has also been experimenting with is this sort of ongoing MLOps process using Vertex pipelines to be able to sort of constantly rerun that sort of embeddings generations or refresh. So depending on if there's like an event trigger, so maybe new data set's been uploaded, data's changed, or we actually start to get new user feedback. So we start to get commentary that we can capture from the analysts as they're going through, that we can then also re-embed and then create back in. So in this Vertex pipeline, this is really powerful in the sense that it's giving us sort of metadata tracking of all of the services that we're using in BigQuery. So for example, right, we're using the text embedding Gecko model. That same query, right, when we're generating those embeddings in BigQuery, where we call, right, we're calling the text embedding model from BigQuery, we're also now tracking artifacts like the destination table, which actual model was used at that point in time. So this is really important if you think about using these types of models either for data augmentation or enrichment. There's a sort of separate side of this where we actually are sort of enhancing the quality of the metadata behind the scene using that generate text function as well. And as you can imagine, you really want to make sure that you're sort of versioned on, what were the queries that were actually sent to do that sort of metadata enrichment, as well as which model version. Because if those aren't associated to each other, then you could start to sort of, you can very quickly lose the plot, right? In terms of like, oh, why are we getting like this JSON output? Oh, did we slightly change the prompt this way? So this is sort of the results where it's like, after we've tested and we're happy, we want this to be rerunning on a regular basis and calling all the BigQuery APIs and sort of get the benefit of all the scaled compute, distributed, but this gives us now the ability to actually start to track all of it behind the scenes. And if you come back to this app, right, you can see sort of the map. We can also now pre-populate a prompt template based off of the results from that vector search. So, we've gotten back sort of the 5 closest embeddings to that sort of site that we had sent, and we can use this to now populate. So considering these destinations, give us some analysis on which will be the most efficient and cost-effective option. So a user can come in and also change this. Maybe they say, historically we've always come from here, but this is a sort of one-off use case where this destination something has changed, right? I don't know. Maybe there's like something stuck in a canal and none of the ships can get past, right? The big ship, something like that. So we're now sending this prompt to Gemini, and you can see here is it's actually giving us pretty detailed reasoning, as well as things like just sort of source citations out of the box. Like you might have seen the launch this week in terms of now being able to ground Gemini in search data and fact. So the analysts are also getting something extra here, right? So they might have their knowledge, but Gemini might also be surfacing net new information for them that they might not have seen before from a source's perspective. And then finally, let's say you want to come in here and provide feedback, right? Because there's always going to be, right, additional context that the model probably doesn't have, that an expert in logistics probably has. So someone can go in, they can provide their feedback to include the quality of responses, right, and submit it here. What will happen behind the scenes then is we'll actually have a table sort of that's capturing that feedback, right, here in our project. So this is obviously a demo, but now as we start to aggregate and collect more and more feedback around specific sort of shipping locations and routes, this updated data will get picked up in that embeddings pipeline and refreshed. So now, sort of as you continuously add more and more feedback from the users, the context that's populated as it goes through and does the reasoning for you, in theory, should be improving over time. And then the last thing I wanted to also mention is sort of what the team has been testing out. So we've talked a lot about sort of the opportunity for data enrichment, right? So it's really amazing, like what Michael had been showing before, to be able to just start to like hydrate the metadata that you might not have had before around certain sites or places. That being said, you're always going to want to make sure that you're probably doing some sort of evaluation or check on it as you're going through. So, as part of this pipeline, whenever there is sort of that metadata generation running, you can also then use this to trigger something like an automatic evaluation job. So in this eval pipeline, right, we're sort of comparing the results. So in this case, we have like Gemini, text, Python, but these could be any models. But the point is that we have sort of our own set of custom-defined tasks in terms of what that metadata enrichment should be doing. And it takes a look at sort of that baseline, sort of this is, at the very minimum, the baseline of what good looks like for these types of responses. And so this is like the logistics experts contributing to that because they actually know the data and be able to automatically run this. So we have a sense, at the very least, is that if we change something or we add more data, we can automatically also run these evals and make sure that it's all sort of full circle coming back. So yeah, I think that's all we have time for from a demo perspective, but happy to chat about it more too. So if you want to find us, definitely.